Alright, so welcome back. So 4.1, the earlier video, we talked about radians. This one, we do a bit more with angles. And this will include coterminal angles, reference angles, and also like sketching angles real quick. So coterminal angles, going based off of just what it says, coterminal. Co means like together, with like corresponding, like co-parent. And terminal means end. So I want to find angles that end at the same spot. So coterminal angles are angles that end up pointing in the same direction. And we use pointing because angles are actually like made up with rays. So with this reference point, like my center, reference being at like straight horizontal to the right, if I have this angle, if I have this ray, I have this angle right here, theta. Or right here, theta. How else I get there is I could also just go backwards. I could go clockwise or counterclockwise and have this new theta, theta 2, theta 1, theta 2. Looking at it, theta 1 and theta 2 are clearly different numbers, different values, but they point me in the same direction. And a lot of times we want to, like this relationship, we call it coterminal angles. And that is important because like I said before, trig functions, this stuff with angles, it is repeating because circles just repeat. We could go once, we could go twice, we go 3 times, we just keep on going more and more. I didn't know that erased, but like we keep on more and more, and that will give us calculations that have the same value. So that's why we want to see coterminal angles. Know that these angles have some relationship to them. Let's think about it real quick. What relationship do you think this has? Like theta 1 to theta 2. Let's also make up a theta 3 as well. So theta 1, theta 2, and since we like to go counterclockwise, I'm going to make a theta 3. So I'm going to go around once and just go back right there. Theta 3. What relationship do you think theta 1 and theta 3 have together? Theta 1, theta 3, that's a Q, theta 3. The relationship, we see theta 1 plus 1 full rotation is theta 3. So theta 1 plus 2 pi is theta 3. If I go around one more full time, I have theta 3. So now let's draw it again so it's not too crowded. But I have theta 1 here. And let's compare it to theta 2. So I'm starting from theta 1. To get to theta 2, I want to go all the way around like that. So theta 2 is this. So to go from theta 1 to theta 2, I must subtract 2 pi. Theta 1 minus 2 pi equals theta 2. And these are coterminal angles. Coterminal angles pretty much use add or subtract 2 pi as many times you want to. And those are coterminal angles. So quick exercise, let's use 3 pi over 4 and let's find 3 coterminal angles. You could pause here, you could do it, or you could follow along as we do it together. So to get coterminal angles, I said before, you just want to add or subtract 2 pi. So just add 2 pi for the first one. I add 2 pi, but it can't just be like 3 pi plus 2 pi gives me 5 pi. That does not work because it's a fraction right here. So to add fractions, I need the same common denominator. So 3 pi over 4, I can't reduce this at all. But for 2 pi, I can change it because it has a denominator of 1. So multiply both sides by 4 over 4. To get 8 pi over 4, and adding them up finally gives me 11 pi over 4. So I see that converting 2 pi, so I can add it to this, I just need to convert it to 8 pi over 4. So 11 pi over 4 is one of my coterminal angles. That's 1. Let's go again, one more time fully around. 11 pi over 4 plus 2 pi. We said before, like we want to add 2 pi. You get the same denominator, multiply by 4 over 4 to get 11 pi over 4 plus 8 pi over 4. And 19 pi over 4. That's coterminal angle number 2. Now, we'll do it one more time, but let's subtract from the original. So 3 pi over 4 minus 2 pi. So a little trick, a little shortcut that we could do is I see the denominator. The denominator is all I care about at this point. The denominators are not the same. Since I'm subtracting 2 pi, I know I must multiply by the denominator. I must multiply both sides by 4. All I'm going to do is just multiply 2 by 4. I know it's 8. I see my numerators up here are always 8. And I subtract 8 from the numerator. So I see this. I'm going to subtract 8 from the numerator. And this will give me negative 5 pi over 4. Because 2 times 4 is 8. So you want to minus 3, like minus 8 pi to get negative 5 pi. And that all this doing is skipping the step of converting it to minus 8 pi over 4. So these little connections are connections I want us to make if we feel comfortable with this method. I want you to understand not just like how to do it, but honestly like be flexible with your understanding so that you can do these tricks. So this is coterminal angles. Reference angles are, there's actually two types of reference angles. The one we'll focus on in this class for now is reference angles are just the corresponding angles, the coterminal angles in the range, in the interval (0 to 2 pi). Including 0 and excluding 2 pi. Because these are the same angles, they're coterminal angles, and you don't need to include both. So we include 0 and exclude 2 pi. So all we have to do is find the coterminal angle to get to this point. And we just test it. Let's test it first with this, negative pi over 7. Negative pi over 7, we can clearly see it's too low. It's below 0. So I'm just going to add 2 pi. Negative pi over 7 plus 14 pi over 7 to get 13 pi over 7. And this is my answer. You don't really need to check because I'm only adding 2 pi, and if it's already below, it won't be above. So let's actually now find one like 31 over 7 pi. 31 over 7 pi. I did 7 again by accident, but like, we'll just stick with it. So this, we'll first need to check, is it too big? Is this bigger than 2 pi? Way to check is get the coefficient of pi, the numbers in front of pi, so 31 divided by 7, and plug into the calculator. What is 31 divided by 7? It won't be a clean number, but I see that 31 divided by 7, this is around 4.429 pi. And that's clearly bigger than 2 pi. It's clearly bigger than 2 pi's, but we'll get to that in a bit. So it seems clearly bigger, so I'm just going to subtract 2 pi. 31 pi over 7 minus 14 pi over 7 to get 17 pi over 7. we do a check once again. We did 17 divided by 7. 17 divided by 7 is roughly 2.429 pi. That's still way too big, so I'm going to subtract one more time. Minus 14 pi over 7 to get 3 pi over 7. And 3 pi over 7 is roughly 0.429 pi. 43 pi. And that is within my range, and I'm happy. So this is my reference angle. So in this class, we use reference angles quite a bit because we will memorize, or we'll get very comfortable using functions from 0 to 2 pi because they do repeat. We don't really care about like 2 pi to 4 pi. I don't really care about negative 2 pi to 0, those intervals. I just care about 0 to 2 pi because we want to really get comfortable with this, and it's easy to convert into an angle that is between this. So this is a skill that we want to be comfortable with. And lastly, we'll sketch angles. So sketching angles, let's just take these two angles for example, 13 pi over 7 and 3 pi over 7. I have no idea what those look like. But on a basic circle, basic curve, like this, we see if we treat straight to the right as 0, so that would be 0. We know that a full circle is 2 pi, so it's also 2 pi. And half a circle we determined earlier is just pi. We want to fill in the gaps. So the gap from 0, this is 0, and over here is pi. Halfway must be pi over 2. And from pi to 2 pi, halfway must be 3 pi over 2. So these are my 4 cardinal directions. We also know it as 0, 90, 180, 270, 360. You might have done that last year, but for now, we're going to stick with radians and get used to seeing radians. And similar to like learning a language, you can kind of jump straight in and only deal with radians, only deal with the language, and you'll pick it up a lot more quickly. So these are my angles. And we actually have quadrants. Quadrant 1, Quadrant 2, Quadrant 3. The significance of them will be determined later. I have these quadrants. When I ask you to sketch an angle, I only care about, are you in the right quadrant? So I have these quadrants. I have my boundaries of each quadrant. So all we do is we just test this value and see, where am I? And the same thing that we did with am I too far? You convert the numbers into a decimal. So 13 divided by 7. 13 divided by 7. This ends up being 1.86 pi, roughly that. If it's roughly 1.86 pi, and this is 0, this is pi over 2, or 1/2 pi. This is pi, or 1 pi. This is 3 pi over 2, or 1.5 pi's. And this is 2 pi's. We want to see, where am I? And I see I'm 1.86, so it must be around here. So this angle is roughly 13 pi over 7. Because I'm 1.8. This is 1.5 pi. This is 2 pi. So it must be in between it and maybe closer to 2 pi. Now the other one, right here. Let's do it again. I have 0, pi over 2, pi, 3 pi over 2. We said before this is 0.429 pi. It should be in between 0 and half a pi, and much closer to half a pi. So let's put it right there. And this angle will be 3 pi over 7. So if you'll try it out, do the last homeworks. And we now know how to sketch a graph, get used to understanding what graphs look like, especially these 4 cardinal points, we know how to find reference angles and coterminal angles, and the significance slightly behind some of it. All right, that's it for today.